In this problem, we have been asked to predict products when we treat propyne with this sequence of reagents. So let's do that step by step and see what is the product that we are creating. So I have propyne. First step says that I treat it with sodium amide. So as we know, that's a terminal alkyne. That's a very strong base and will be used to make an alkynate anion. So that's my first step. The second step here is I'm trying to see make the best use of my board. So second step is a methylation. We use a metal iodide, and is what we have seen before. That alkylation is an SN2 reaction, and what you're doing then is the SN2 attack over here. So at that point, we had created the following. We had created 2-butene. Okay. Now, what's next? It says that we use Lindlar's catalyst. So in that step, we know that Lindlar's catalyst is used to make cis alkenes. So the reaction happens adding hydrogen across the double bond in a same fashion. That's the mechanism. So if I treat then, as we said here, reaction 3. That was reaction 2. Reaction 3, we're using this condition. With Lindlar, we are going to make then the alkene that cis. I'm sorry. Yeah, that. The cis to butene. So when you do that, that's your product after Lindlar's. Then it says condition 4. So condition 4 here is bromine in carbon tetrachloride. So what are we doing in this step? We're adding bromine across the double bond. But we need to remember that this reaction proceeds in anti-fashion, meaning that the bromine atoms that we're going to be adding are being added to opposite sides. So if we're doing that, let's draw the product that results. We're going to be adding, say, bromine, 1 in wedge and 1 in dash. That's what I'm doing. So bromine, bromine. So opposite sides. And that would make that plus E enantiomer. So that is a racemic product. Again, what we did in this problem then is step by step. We remove in the first step an acidic hydrogen, will form an alkynate. Second step is an alkylation, an SN2 reaction, very favorable with a metal iodine. And so we have created 2-butene. In the third step is the zinc hydrogenation using a Poisson catalyst to get cis 2-butene. And then we have the halogenation, but remember, this goes through bromine intermediates, so the 2 bromine atoms are going to be added opposite sides. And you can do that also with that, so that plus the enantiomer. Therefore, the product is racemic.